This problem states that there's a gas mixture consisting of 2 kilograms of nitrogen, 1 kilogram of hydrogen, and 4 kilograms of CO2. And then it asks us to find the mass fraction and mole fraction of H2, and then the apparent molar mass of the total mixture. So first we're going to go to test calcs. And we could do either system or flow state for this part, since we're just doing the states for parts A, B, and C. But later we're going to be doing a flow problem, so I'm just going to go straight to flow. And then we're going to assume the PG model. So we'll go to the n-PG model, and we'll create our gas mixture. So up here it says specify in kilograms, which is what we want, but we also could have done by percent mass, percent mole, whatever it gave it in. So it was 2 kilograms of nitrogen, 1 kilogram of hydrogen, and 4 kilograms of CO2. And we'll just hit add right there. So the first part of the problem asked us to find the mass fraction of H2, and then the second part asked us to find the mole fraction of H2. So that's super easy. It's just right here. We go to the H2 row, and then mass fraction is X sub K. So the answer for that is just 0.143. And then the molar fraction is the Y sub K. So the answer for that is just 0.754. The next question asks the apparent molar mass, which means the molar mass of the whole mixture. And that is going to be right here in the middle under mixture A. And so the total molar mass is going to be 10.63 kilograms per kilmoles. So that's it for the state problems of that. Now we can use this mixture in our state panel to just evaluate it and use it like any other problem that we've been doing in the PG models. This one specifically asks us to find the mass flow rate if the mixture is at 100 kPa, 200 degrees C, and is flowing through a 1 meter squared pipe at 10 meters per second. So we know that m dot equals rho AV, and we're given A and V, so all we really need is the rho. So the rho is going to depend on the pressure and temperature as well. So we're going to enter those, which we're given as 100 and 200 degrees C. And then we were told it was 10 meters per second and 1 meter squared for the area. So we can hit calculate after that, and you can see it calculated the rho for us, and that's the density of the whole mixture. And then there's our answer, 2.7 kilograms per second for the mass flow rate. The next part of the problem asks how would m dot change if N2 were replaced with O2. So to do that, we'll go back to the composition panel. We can either remove that N2 and then re-add O2, or a better way would be to create a new mixture, mixture B. And we'll just re-enter that. So instead of 2 kilograms of N2, it's going to be 2 kilograms of O2. It's still going to be 1 kilogram of hydrogen and 4 of CO2. Alright, and you can see that the molar mass actually changed a little bit. So back to the state panel. Right now we're on mixture A, so we're just going to change that to mixture B and hit calculate. And the m dot actually went up to 2.74 because the rho also went up because oxygen is heavier than nitrogen.